Now we're going to look at how we can use Sklearn to actually fit our logistic regression model. So just as a reminder of the modeling process and where we left off, we had chosen a model. We chose the loss function in our last video, and now we're going to look at how we will use Sklearn and regularization to fit the model. In this video, we actually won't be using any regularization, but in the next video, I will show you how and why regularization is the default in Sklearn's model fit for logistic regression. So let's pop over to the notebook and do it in there, and then I'll come back and summarize in these slides. So we are in the modeling folder, in the logistic regression subfolder, in the logistic regression notebook. And we are going to continue working with the data set that we already loaded in the previous videos that looks at whether or not tumors are malignant or benign. So you can jump down to the part here that says fitting a logistic regression model with Sklearn, and that's where we'll be starting. Just as a reminder of the data that we're working with, let's look at the head here. So we have the average radius of a tumor here, and then in the Y, so that's what we're going to use to predict. And then in our Y series, we have whether or not it's malignant. So we either have zeros or ones for the entries of the series, with 0 being benign and 1 being malignant. So if we want to visualize this, a quick way to do this, we can actually use the Seaborn function strip plot, which will auto plot jitter data so we don't get the data all overplotted on top of itself. And so here, this is the data that we're actually going to try to fit with our S-curve. So ideally, I'm just going to eyeball it here. I'm going to come up with some best shaped S-curve, right, that I'm going to use that gives me a probability, some value between 0 and 1 for a given mean radius input. What's the probability that tumor is malignant or not? Okay, so let's fit this best shaped S-curve by minimizing the cross entropy loss. That's actually done all underneath the hood in Sklearn. So here's the form of the model again. I'm only using one predictor right now, the mean radius. I will include an intercept, but that means that our sigmoid function that we're trying to fit is this form. And so I'm trying to find what's our best fit theta naught and theta 1 given this training data. So to do this, we're going to use the built-in logistic regression function, and it's very similar to what we've done with ordinary least squares and simple linear regression. But I will point out that the documentation, it's important to read through this because this documentation actually has quite a few input values that are slightly different than what we've worked with before. In particular, the first one is actually this regularization input. Logistic regression, the built-in function here in Sklearn, by default actually includes L2 regularization. And I'm going to point out in the next video why that is actually a very good default to go with in the case of logistic regression. But for now, because this is our first example and because of the data that we're working with, I'm actually going to start without regularization. So we're going to switch that default parameter to be none. We are fitting an intercept. That is the default parameter, so that's already there. And then you do have some options about what numerical solver you want to use, and there's a lot of information about that here. So just pointing this out, and the choice of the algorithm that you want to use does depend on your type of regularization. So the default here works for both L2 and none, so that's what I'm going to stick with. But just pointing out, there's actually quite a few customizable things in this built-in function. Okay, so what we are going to set here is our penalty as none, and then the fit intercept true is already the default, so I don't even have to put that. So to initialize this, I'm just going to have logistic regression, and then I will put penalty equals none. Okay, and there's my initialization. And then I'm going to fit the model. So now I'm going to do model.fit, and I put in my training data. And now I have the fit model. We've come up with our best fit theta 1 and theta naught by minimizing the cross entropy loss. That is all the default settings in sklearn. So if you want to see those best fit values, you can call this intercept and coefficient attributes. We can see there's our intercept and there's the coefficient for mean radius. So how does that relate? How can we go back to visualizing what our S-curve now looks like? First, let's give you one input value. I'm going to have us take an input of 15 and have us give what output the model gives. So like what the value here would be on this red curve. Again, my model is probability that y is equal to 1, that the tumor is malignant. So how do I get that out of sklearn? This is actually stored in a method called predict proba. So I'm going to do model.predict proba, and then I'm going to put in the radius that I want. I'm doing double brackets because it's assuming that I have a data frame form. And this is going to give me a warning right now because I didn't put a column title here, but I know that this X value, or my X data frame, actually only has one column in it, mean radius. So this is legit. I can just ignore this warning. But what do these outputs mean? So if you forget, you can use the .classes attribute here to see exactly what these represent. This means that the first entry represents the probability that a tumor with mean radius 15 would have an output of 0. In other words, that it's benign. And the second value here is the probability that the tumor is malignant. And so the second value is what we're actually plotting for our model, probability that y is equal to 1. And so to visualize this, I'm just going to point out that we can grab these probabilities for more than just one data point here. So let's actually grab these probabilities for, let's do model.predict proba, and then I will put X as the input, and I want to just grab the second column. And so now let's just do, it's still an array. So now you can see the first 1, 2, 3, 4, 5. I mean, these are a ton of entries, but just look at the top line here. And this is giving these probabilities for each of these different mean radius inputs. Now it's a little bit tricky to see here because you can't actually see what the mean radius input was without going back. Here, let's go back to this just to show you, because this is basically what we're going to use to plot our S-curve. But if you want to see how it corresponds, come back to this. Okay, so this very first entry corresponds to the probability that a tumor with mean radius 11.8 would be malignant. So that's a small probability. It's likely not going to be malignant. What about if it has radius 17? Okay, now it looks like it could likely be malignant because now it's around a 90% chance of being malignant. So that's how these are lining up. This output here are just the probabilities that correspond to these different mean radius that was in my X data frame. All right, so let's plot this now to see what our S-curve actually looks like. So that's what I'm going to put in here. I'm replotting the original data set that we are training data. So this is the exact same code that I had above when I just plotted our training data. And now I'm going to add over it in green our model predictions. Okay, and then we can plot these on top of each other. There we go. And we can see what our model's predicting. So you can see here for a mean radius of 15, right? Yep, the model is predicting right around 55%, right around there. So depending on our classification cutoff, we may bump that to an output of 1. We have to, at the end of the day, pick a cutoff here for which we're going to either push these values down to 0 or bump them up to 1. And that's what we do with the predict function that's built in here. So let's go to the next part of this. The built-in threshold is to say if the probability is greater than or equal to 0.5, let's classify it as a 1, 0 otherwise. But again, this is something you can play with, which we'll be talking about in future videos. So let's see what Sklearn's prediction would be if we use a cutoff of 0.5 for our mean radius of 15. If you recall, mean radius of 15 had a probability of about 55% being malignant. So that should get classified as a 1. It should get bumped up because it's above our 50% cutoff. But let's see that in action. How would you see that in Sklearn? So now you're just going to do model.predict. And then you can put in the value. And there you can see it gets output to a 1. So let's visualize the predictions now. And I'm going to keep our cutoff of the built-in cutoff of 0.5. So I'm saying predictions is this. Again, I could also, I'm doing it manually here just so we can play around with the threshold, but I could also just call model.predict right here, and I don't have to include this greater than or equal to piece. But now let's visualize, there we go, what our predicted classes are. So now you can see, I'm gonna highlight this here, that exactly at, this is our 50% cutoff right there. And so you drop down right here and there's some mean radius that corresponds, something slightly less than 15, right? That's going to be what's called our decision boundary. So any tumors that have a radius less than that are going to be classified as benign, and any tumors that have a radius greater than that will be classified as malignant in this model. And you can see that we are going to incorrectly classify some data points. That's what I've highlighted in red. These are data that's incorrectly classified by our model. So up here, our model is classifying these as malignant when in fact they were actually benign. Okay, and so we will use this to assess our model. We'll actually look at how many of them did we correctly classify. We'll look at that in a couple of videos from now. But this is just, at this point, wanting you to visualize what you get from the results of Sklearn and how you can access the probabilities, which is shown here in this blue curve, as well as their actual classes. So let me put all of this into a data frame. So in order to store all of this, I am going to create a data frame that has the original mean radius, the actual classification, this is the real information, this is the model predicted probability that it was malignant, and therefore the predicted class using a threshold of 50%. So this now summarizes our original data set we used to train and the output of our model. Let's jump back to the slides to summarize this. So what did we just do in the notebook? We looked at how we can use Sklearn's built-in logistic regression function to fit our model. And just as a reminder, what's happening underneath the hood is it's using a model of this form, and it's fitting the average cross entropy loss. So we're trying to minimize that loss. And as I pointed out, the built-in function will add regularization. We took it out for our example, but in the next video, I'll talk about why it's really useful and why you'll likely want to leave it in. And then we realized we can get several pieces of information predicted out of this. The first is the probabilities, which are represented here by this S-curve. And then the second is the actual classes that we are going to bin our results in. So using a threshold, the default threshold of 50%, we found these classes that we binned our data into, and that was output here in this column of our data frame. So that is an overview of how you can do all of this logistic regression model fitting using the built-in Sklearn functions, with a reminder of the functions and the loss that's really underneath the hood that's built into all of this. In the next video, we're going to talk in more detail about why you need to use regularization when you are using logistic regression in most scenarios, and show you how you can do that again in Sklearn.